All right, so we're running the two-sample z-test for the difference of these proportions of Black and Hispanic females in STEM and non-STEM programs at this university. So we're going to head over to staplet.com. So we'll open a new browser and go to staplet.com. Hello, this is me. And we're going to scroll down to to traditional inference, and we're looking for a two-sample z-test for proportions. So there it is. We're going to fill in all the information that we need. So our variable name, our students at this university. We have STEM and non-STEM groups. We have one category is the Black and Hispanic females. And then in STEM, there are 12. In non-STEM, there are 75. And we have others that there's 288 to make up 300 STEM students in the sample and 425 to make up the 500 non-STEM students in that sample. We'll hit begin analysis, and we can see graphically a few different ways here. Let me zoom out so we can see the whole thing. So you can see a segmented bar. You see that the relative frequency on the vertical axis here shows that it looks much smaller. It even says 4% and 15% versus 96 and 85%. Change it to a mosaic plot. That's just a prettier looking bar there. And we can do side by side. I kind of like this one. This mosaic plot looks pretty cool. We have summary statistics down here showing that there's 4% females, Black and Hispanic females in STEM, 15% in non-STEM. But what we want to do is we want to actually perform an inference down here. So we're going to go all the way down to the bottom, inference procedure. We want a two-sample z-test for the difference of proportions. So that minus is difference. P is for proportions. That's good. Our alternative hypothesis is that the P1, which is the STEM sample proportion of Black and Hispanic females, is smaller than the non-STEM proportion. And Black and Hispanic females is our success. We'll run the inference. So this is good. All the work I would need to be seeing here. Got a z-value, negative 4.8. We learned that outside of negative 2 and 2 is pretty unusual. So our p-value, our probability of this happening randomly, if there was no difference between these proportions, is very, very small. That's what less than 0.001 means. Really, really small. Less than 0.1%. So we can take a little screenshot here of our inference procedure. We'll take a picture of our graphs as well. Basically everything that we've thrown in here. Selection tool. So there's that. We can go grab the graph and our data there, get me out of the way. Has that on there. Even got some of my little window down below on there. So we got that, looks good. And then let's get this summary statistics as well, because why not? Copy that and throw that over. All right. So now once we have that all copy pasted over, we can come up with our conclusion, which is where we're going to be comparing this p-value of less than 0.01 to our alpha significance level of 5% or 0.05. So we can conclude and say that since the p-value is less than the alpha, and that was smaller than 0.01, is less than 0.05, then let's see here, then we will, since that p-value is less than the alpha, we skip down to the next page. We reject the null, that there is no difference between the proportion of Black and Hispanic females in STEM and non-STEM, we have significant evidence that the proportion is smaller in STEM than non-STEM for Black and Hispanic females. So we make a conclusion, we reject the null, and we talk about our significant evidence with context. So some important ideas down below. We want to talk about our hypotheses. So our null, H sub 0, is going to be the proportion of our first sample minus the proportion of our second sample equals 0, that there is no difference between the proportions. Our alternative, which is H sub A, our alternative hypothesis, will be that they're either that it's greater than or less than or not equal to 0. So one of those three. So you'll choose one of those three. Choose one. And that'll be basically either what you're thinking or what the problem's claim is. So in Staplet, we go to 2 sample. Make sure I have this one right. 2 sample Z test for proportions. On the calculator, we go to, where's my calculator at? We would go to stat tests, number 6 is a 2 prop Z test. If our p-value is less than alpha, we reject the null. If our p-value is greater than alpha, we fail to reject the null. And then we want to give context in our conclusion. Zoom out and get you all of that. So for our hypotheses, null and alternative, null is always equal to 0, that there's no difference between the proportions of our 2 samples. Our alternative will be either greater than, less than, or not equal to 0. You'll have to choose one of those, and it's either based on your own claim or the problem's claim. And a couple different ways to do this, either on Staplet or on the calculator. And then what we conclude, we either reject or fail to reject the null, and we want to give context as well. You're going to have some options to practice down below. I think we got 3 problems I want to say that you can practice and work together and ask questions. Good luck.